today's topic is based on the FIR filter realization using the linear phase realization. For a linear phase FIR filter, so we have linear phase relation is, the condition for linear phase is h of n is equals to h of n minus 1 minus n. So this condition again we will know about in terms of FIR filter designing. So remember this condition for finding the linear phase. So give it as equation number 1. Now let us consider h of z is equals to the impulse z transform of the impulse response, that is h of n into z power minus n. Now so between n is equal to 0 to n minus 1, we have n values which are in odd in condition as well as even in conditions, right? So let us consider n, I am considering it as even value. Then the same, this above expression I can equate it as summation of n is equal to 0 to n minus 2 divided by 2 h of n into z power minus n plus n is equal to 0 to, that is n by 2 to n minus 1 h of n into z power minus n. So here what I am doing, I am dividing with two separate. So I have the length of the sequence is between 0 to n minus 1. Between 0 to n minus 1, I am considering it as n by 2 minus 1 and n by 2 to n minus 1, right? Same expression, I have splitted my summation as two halves, one half based on, because I am considering n as the even function. So give it as equation number 2. Now substitute, so we have a equation number 1. Substitute equation 1 and equation in 2. Thereby we have h of z is equals to summation of n is equal to 0 to n by 2 minus 1 h of n z power minus n plus summation of n is equal to 0 to n by 2 minus 1 h of n into z power minus of n minus 1 minus n. From the above expression, take the common factors, that h of z is equals to summation of n is equal to 0 to n by 2 minus 1. If I take h of n as a common in between, then I have z power minus n plus z power minus of n minus 1 minus n. So this is a common factor, give it as equation number 3. Now if I substitute the n value between 0 to n by 2 minus 1, then I have h of n, that is a coefficient. Suppose if I substitute n is equal to 0 in the above expression, then z power minus 0, that is 1, plus z power minus n minus 1. Okay, so there is a adder in between these two. So we have a adder to combine this first value as well as the last value. Suppose n is equals to 1, then I have z power minus 1, here z power minus of n minus 2, right? So same, if you are drawing in terms of a structure, so h of z I can write it down as y of z by x of z. Then again cross multiply, then I have, if I apply the inverse z transformation, then the following structures I will get it as, first input is x of n, Then we have z power minus 1, that is x of n minus 1, next x of n minus 2, and so on. So when n is equals to even, capital N is equals to even, we are dividing this entire structure as two halves, right? So first and see that first line and last line will have same number of delay elements. So here also I have one delay element, then so this is a structure for the linear phase realization. So in the linear phase realization we have the equal parts, equal number of delays on the upper part and lower part. These two are added by adder circuit, and those are multiplied by the coefficient h of 0. If n is equal to 0, h of 0. If n is equals to 1, h of 1. So all these are connected by again adder circuit. So this is the overall structure for linear phase realization. If you are identifying for n is equals to odd value, so this is the first delay and this element is the last delay, right? So we have the linear phase realization, that is h of n into z power minus n plus z power minus of n minus 1 by n. In the same factor, we have h of n, that is a coefficient. So this coefficient I am giving here with the adder multiply by h of 0 first coefficient. Again h of 1 second coefficient, h of 2 third coefficient, and so on. The last value is h of n minus 1 is the last value, and so on. And this is last before value, that is h of n minus 2 by 2. And here we have one more value, that is h of n minus 1. And careful while giving the arrow marks, be careful. Now all these connections are being added by this adder. And so on. Then we have one more adder here. So these all lines are directed towards the output y of n. If you are identifying the n value which is odd value as well as even value, this structure is same, but you have for n is equals to even values, you will have one more z power minus 1 delay in between these two. We have one problem to solve using the direct form 1 as well as the linear phase realization, and given impulse response h of n is equals to 1 by 2 del of n plus 1 by 3 del of n minus 1 plus del of n minus 2 plus 1 by 4 del of n minus 3 plus del of n minus 4 plus 1 by 3 del of n minus 5 plus 1 by 2 del of n minus 6. So this is our shifted impulse response. Del of n is impulse response, that is equals to 1 for n is equal to 0 and 0 for n not equals to 0. Similarly, del of n minus 1 is equals to, again it is 1 if it is a unit impulse. Here the impulse response is given 1 by 3. Okay, amplitude is 1 by 3 for n is equals to 1 and 0 for n not equals to 1. So we have an impulse response. So this impulse response we have to realize the same using the direct form 1 as well as the linear phase realizations. H of n is equals to, so give it as equation number 1. Now using the linear phase realization, we know the condition for linear phase filter is the h of n is equals to h of n minus 1 minus n for all n values. Now, from the given expression, we come to know that the order of the filter is 7. If it is 7, the n value is in odd in nature. Now, substitute the same in the above expression. So, we will get 7 minus 1 minus n is equals to h of 6 minus n. So, h of n is equals to h of 6 minus n. Now, consider first value n is equal to 0 and substitute. If I substitute h of n is equal to 0, h of 0 is equal to h of 6. If I substitute n is equals to 1 in this expression, h of 1 is equal to h of 6 minus 1, that is 5. N is equal to 2, then h of 2 is equal to h of 4. N is equal to 3, then h of 3 is equals to again h of 3. Now, from the given expression, see, first coefficient n is equal to 0. For n is equal to 0, what is the coefficient I have? 1 by 2. Now, check the last coefficient. What is the coefficient I have? 1 by 2. Now, it is 1 by 3 and it is 1 by 3. Then here it is 1, here also it is 1, right? Now it is one common factor. Okay? Now, if I substitute, this is a coefficient h of 0 is equal to h of 6. What is the coefficient is given? 1 by 2. Next coefficient 1 by 3. Next coefficient which is 1 and h of 3 coefficient which is 1 by 4. So these are all our linear phase relationship. So using the same linear phase, we have the first coefficient is equals to last coefficient. Next coefficient is equal to last but one. Okay, and so on. Now, here we can check the linearity condition has been satisfied. Then, therefore, given system satisfies the linear phase condition. Satisfies the linear phase condition. The linear phase condition. Now, we have h of z is equals to the z transformation of h of n is equals to same n is equal to 0 to n minus 1 h of n into z power minus n, and we know n is equal to 7. Therefore, h of z is equals to summation of n is equal to 0 to 7 minus 1, that is 6 h of n into z power minus n. Now, substitute these n values between n is equal to 0 to 6. If I substitute n is equal to 0, I have h of 0 z power minus 0, that is 1, plus h of 1 into z power minus 1, plus h of 2 into z power minus 2, h of 3 into z power minus 3, plus h of 4 into z power minus 4, plus 5 into z power minus 5, h of 6 into z power minus 6. Now, we know h of 0 is equals to h of 6. Same, h of 1 coefficient is equals to h of 5 coefficient. Now, I am taking a common values. Okay. So, if I take h of 0 as a common in this first term and last term, right? So, I will get 1 plus z power minus 6 plus, if I take h of 1 and h of 5 as h of 1 as a common, h of 1 if I taken a common, z power minus 1 plus z power minus 5 plus So here h of 2 and h of 4 are same. See, I am giving common, representing common with different indications. So here I have given this factor and this. It means this coefficient is equals to this coefficient. And this h of 1 coefficient is equals to h of 5. H of 2 is equals to h of 4. And this is a common overall. Then if I take h of 2 as a common, I have z power minus 2 plus z power minus 4 and remaining factor which is h of 3 into z power minus 3. Now if I substitute the h of 0 coefficient, then h of z is equals to h of 0 coefficient is 1 by 2, h of 1 is that is 1 by 3 and h of 2 coefficient is 1, h of 3 is 1 by 4. Now substitute the same in the above expression. You will have 1 by 2 into 1 plus z power minus 6 plus 1 by 3 into z power minus 1 plus z power minus 5 plus 1 into z power minus 2 plus z power minus 4 plus 1 by 4 into z power minus 3. Now we know that transfer function is equals to h of z is equals to y of z by x of z. Now substitute the same in this formula. So 1 by 2, 1 plus z power minus 6 plus 1 by 3 z power minus 1 plus z power minus 5 plus z power minus 2 plus z power minus 4 plus 1 by 4 into z power minus 3. Now cross multiply this x of z to the right handed side. Then you will have y of z is equals to 1 by 2 x of z plus z power minus 6 into x of z plus 1 by 3 which is a constant, z power minus 1 into x of z plus z power minus 5 into x of z plus x of z that is z power minus 2 into x of z plus z power minus 4 into x of z plus 1 by 4 z power minus 3 into x of z. Now apply inverse z transformation on both sides. If I apply, after applying the inverse z transformation, we will get y of n is equals to first constant 1 by 2 x of n plus z power minus 6 into x of z becomes x of n minus 6 plus 1 by 3 z power minus 1 into x of z becomes x of n minus 1 plus x of n minus 5 plus x of n minus 2 plus x of n minus 4 because the coefficients are only 1 into and last value 1 by 4 x of n minus 3. So give it as equation number 2. So this is our final expression and thereby we will designing our realization, circuit realization using linear phase. So if you are identifying what is the input here, input is x of n, output is y of n, the output is y of n, right? So first input, now whenever it is delayed by one sample, it will generate x of n minus 1. Again after delaying by one more sample, it will generate x of n minus 2. Then we have x of n minus 3, that is z power minus 1. Okay. So totally we have the n value that is 6. 6 I am dividing as first 3, next 3. Okay. So first, for the first part I have generated the up to n minus 3. Now suppose if it is again going through by one more sample z power minus 1, there it will generate the x of n minus 4. Now again one more sample, then x of n minus 5. Again one more sample, it will generate x of n minus 6. So remember, here we have the n is equals to odd value. So therefore, we have generated x of n to x of n minus 6. So we have generated based on the expression x of n to x of n minus 6. Right? Now see, here x of n plus x of n minus 6. Right? Now where I have x of n? So this line corresponding to x of n and this line corresponding to x of n minus 6. Now how these two are connected? These two are connected by adder. Right? So this arrow mark plus, this plus. Right? Now what is the coefficient here? The coefficient is 1 by 2. So this is our coefficient, that is h of 0 is equals to 1 by 2. Now similarly, next expression x of n minus 1 plus x of n minus 5. This is a line which contains x of n minus 1 and here we have x of n minus 5. Now tell me how these two are connected? By again one adder. What is the coefficient here? The coefficient is 1 by 3, that is h of 1 coefficient. Again x of 2 plus x of n minus 4. So this is a line which contains x of n minus 2 plus x of n minus 4. What is the coefficient here? The coefficient is 1, that is h of 2. Alright. Now we have one more factor, that is 1 by 4 x of n minus 3. Now tell me which line is x of n minus 3? This particular line is x of n minus 3. Now extend this line to give a coefficient, that is h of 3 is equals to 1 by 4. Now tell me how all these terms are connected. This is term 1, 2, 3 and 4. Okay. So we have generated 1 by 2 into this first term, 1 by 3 into second term, 1 into third term and fourth term. Right? All these are again how these are connected by, suppose, adders. Okay. Now I am connecting this with one adder with the direction. Again this will connect with the one more adder. Now again it will connected by one more adder circuit. Therefore this is my final output, that is y of n. This is our final circuit for the given impulse response using linear phase realization. So for each and every realization we have a specific procedure. Using the direct form realization, so first given expression is h of n is equals to 1 by 2 del of n plus 1 by 3 del of n minus 1 plus del of n minus 2 plus 1 by 4 del of n minus 3 plus del of n minus 4 plus 1 by 3 del of n minus 5 plus 1 by 2 del of n minus 6. Now solution. The given h of n, write all the coefficients, that is h of 0, h of 1 coefficient, h of 2 coefficient, that is 1, next 1 by 3, 1 by 4, 1, 1 by 3, 1 by 2. So this is considered as h of 0, h of 1, 2, h of 3 coefficient, 4, 5 and h of 6 coefficient. Now we know that the jet transform of impulse is summation of n is equal to 0 to n minus 1, h of n into z power minus n. Now what is n value? How many coefficient we have? 7. Therefore n is equal to 7. So n is equal to 0 to 7 minus 1, that is 6, h of n into z power minus n. Now substitute n is equal to, starting from 0 to 6, h of 0 z power minus 1, h of 1 into z power minus 2, h of 2 into z power minus 3 plus 3 into z power minus 4 h of 4 into z power minus 5. Here it is 0, it is 1, 2, it is 3, 4, h of 5 into z power minus 5 plus h of 6 into z power minus 6. Now from the above values we have all the coefficients. Just to substitute the coefficient, 1 by 2 plus 1 by 3 z power minus 1. Next 1 into z power minus 2 plus 1 by 4 into z power minus 3 plus, now multiply this y of z, write down the y of z as h of z as y of z by x of z, and multiply x of z to the right handed side and apply the inverse Z transformation, then you will get the structure. Now this is our final circuit for the given impulse response after applying the inverse Z transformation, and this is our designing using the direct form realization. Thank you.